Alrighty guys, here's a video for you explaining worksheet 5.3 WSPM. How do we solve an inequality? Well, you solve it the same way you would solve an equation. The only difference is on your last step, if you multiply or divide by a negative, you have to change the inequality symbol. So imagine that this were an equation. You want to solve for b. You want to get b by itself. You're going to get rid of the 4 first by doing the opposite. Minus 4, minus 4. You're going to rewrite it. So negative 2b is greater than negative 10. And then you got to get rid of the multiplication of negative 2 in front of the b. So the way to get rid of the multiplication is division. You're going to divide by that same exact value, negative 2, and divide by that same exact value, negative 2. So we need to remember that if you multiply or divide by a negative on your last step, you must change the inequality symbol. Okay, that's what we have written on the board. So remember that this is our last step. We are dividing by a negative 2. So because we're dividing by a negative, you're going to end up with b. You're going to have to flip the inequality symbol. So that greater than became less than, or you change it, not flip it, whatever you want to call it. And a negative 10 divided by a negative 2 is a positive 5. So b is less than positive 5. And it might be a good idea just to review on how to graph that answer. B is less than positive 5. You would draw a number line. You'd put 5 right here in the middle, and then 6 and 7, and over here 4 and 3. Obviously, anything on the left side is less, anything on the right side is greater. So because this is a less than symbol, you're going to put an open dot at 5 and going to the left, okay? It's an open dot because it does not have a solid line underneath it. If it had a solid line, you would include the 5, but it doesn't, so you just leave it open. And it is a less than, and anything that's less is to the left, anything that's greater is to the right. Not only that, if you take a look at the inequality, less than, it looks like an arrow pointing to the left, and that's exactly what it does. It goes to the left. Let's move on to the next question. Once again, you solve it exactly the same as you would an equation. Just remember that on your last step, if you multiply or divide by a negative, you have to flip that inequality symbol. So let's solve by getting rid of the 15 first. We're going to subtract 15 to get rid of the plus 15. What you do to one side, you do to the other side. Subtract 15. Rewrite the whole thing. It's 3x. Bring down the inequality. Less than or equal to 21 take away 15 is 6. So you have 3x is less than or equal to 6. And to get rid of the 3 that's in front of the x, that's really a times 3. To get rid of multiplication of 3, you're going to do the opposite, which is divide by 3. What you do to one side, do to the other. You're going to end up with x, and 6 divided by 3 is 2. Now the question is, do I flip the inequality symbol or do I keep it? Remember, on the board it says, if you multiply or divide by a negative on your last step, you change the inequality symbol. Did we multiply or divide by a negative? No, we divided by positive 3. So you don't change the symbol. It just stays exactly the way it is. X is less than or equal to 2. Let's graph it quickly on a number line. Put the 2 right in the middle. Bigger values on the left side, smaller values on the right side. Because this inequality has a solid line underneath it, that will be a solid dot. So you're going to fill in the dot, make it solid, and it is going to the left because that is a less than or equal to. Solid dot going to the left because it's a less than. It even looks like an arrow pointing to the left, right? Moving on to the next one. Again, you want to solve for the variable. You want to get the variable by itself. You have a minus 1 and a divided by 2. Which one should you get rid of first? I mean, you could go either way, but I prefer to get rid of this minus 1 because it's really easy to get rid of a minus 1. All you have to do is do the opposite, plus 1. And when you do to one side, you do to the other side. Okay, that will eliminate. You will have d divided by 2 is greater than or equal to, and of course 3 plus 1 is 4. Now all you have to do is get rid of this division of 2. And again, if you ever have a fraction, you could get rid of any fraction by multiplying everything by the denominator of the fraction. In this case, if you want to get rid of the divided by 2, or you want to get rid of that fraction, go ahead and multiply by that denominator. And notice that I put the times and the 2 up on top because when you have 2 over 2, that's when it cancels out. But then again, what you do to one side, you must do to the other. So let's multiply by 2 over here. So yes, that does eliminate. You end up with d. 4 times 2 is 8. and I do not change it. I keep it. I do not flip the inequality symbol. I don't change it. I keep it as a greater than or equal to. That's kind of ugly. And why is that? Again, because you need to understand that if you multiply or divide by a negative on your last step, that's when you change the inequality symbol. We did not multiply by a negative. We multiplied by a positive. So that's why I did not change the inequality symbol. Number 6, we want to get a by itself. How do you get rid of this minus 4? I mean, you could get rid of the fraction first, but I would rather get rid of the minus 4 first, right? How do you get rid of that minus 4? You're going to do the opposite, plus 4. And what you do to one side, you do to the other side. So you're going to end up with 2/5 a. Bring down the inequality is less than 2 plus 4 is 6. Again, 2/5 a comes down, inequality comes down. This canceled out. 2 plus 4 is 6. Now we want to get a by itself. I don't want a fraction. It would be nice if I could get rid of this divided by 5, and you can. How do you get rid of something? You do the opposite. If you have it divided by 5, all you have to do is multiply by 5. And what you do to one side, you have to do to the other side, multiply by 5. Now, you're not really multiplying on this side. You actually just cancel it out. I mean, you could multiply and say 5 times 2 is 10, and then 10 divided by 5 is 2, but it's easier to just cancel it out. So we end up with 2a is less than 30. All I need to do is my final step here of getting rid of the multiplication of 2 in front of the a. And of course, to get rid of multiplication, I do the opposite of multiplication, which is division. Divide by 2, divide by 2. Now, this is our last step. So that does cancel out. I do end up with an a, and 30 divided by 2 is 15. However, I did not divide by a negative 2. I divided by a positive 2. So the rule only says you change it when you multiply or divide by a negative, right? It says right here, understand that if you multiply or divide by a negative on your last step, you must change the inequality symbol. I did not multiply by or divide by a negative. I divide by a positive. So that symbol, that less than symbol, is going to stay exactly the same. So there's my answer. A is less than 15. How would you identify that on a number line, or how would you graph it on a number line? You would put 15 in the middle, and you'd put a value or 2 that's greater on the right side, 16, a value or 2 that's less on the left side, so 14. And this will be an open dot because it does not have a solid line underneath it. If it had a solid line underneath it, it would be a solid dot, but it doesn't, so that's going to be an open dot. And this is a less than symbol. I mean, even if you forgot that it was a less than, it looks like an arrow pointing to the left, so it's going to be a less than that's going to the left. That's how you graph it. Moving on. Number 7. You want to get t by itself on the left side of this inequality? We have to get rid of things. You could get rid of the divided by 5. You could get rid of the plus 7. You could get rid of that minus sign. I'm going to start by getting rid of that plus 7 by doing the opposite of plus 7, which is a minus 7. And what you do to one side of the inequality, you must do to the other side of the inequality. So what do I have left? The 7 and the negative 7 cancel out. I do have a negative t over 5 with the greater than symbol, and a negative 4 minus 7, that's a negative 11. So from here, I need to notice that I moved that negative, I moved it up to the t, all right? No problem. Or you could have, well, yeah, I'm going to leave it up there with the t. So let's get rid of the division of 5. Let's get rid of the fraction by multiplying both sides by the denominator, 5. And when you do to one side, do to the other. So the 5s cancel out. I now have a negative t, or a negative 1t, if you want to call it a negative 1t, is greater than negative 55. Finally, I need to get rid of that negative sign by multiplying both sides by negative 1, or get rid of the negative 1 that's being multiplied by t right in front by dividing both sides by negative 1. And of course, we are either multiplying by negative 1 or dividing by negative 1. This is our last step, which means that we need to change the inequality symbol, okay? So this does cancel out. I end up with t, change the inequality symbol from a greater than to a less than, and negative 55 divided by a negative 1, that is a positive 55. And that's the answer. To graph it, if you wanted to graph it, you'd put 55 in the middle. You could put a bigger number on the right side, 56, a smaller number on the left side, 54. This is an open dot because it does not have a solid line underneath it. So that's going to be an open dot going to the left because that's a less than symbol. Anything on the left side is less than. Anything on the right side is greater than. Moving on. We want to solve for this variable j. I'm going to get rid of the minus 10 first by doing the opposite of minus 10, which is a plus 10. What you do to one side of the inequality, you must do to the other side of the inequality. Let's rewrite what we have left. We have a negative 3/4 j left, so bring that down, 3/4 j. Bring down the greater than or equal to, and 5 plus 10 is 15. So I now have a fraction in front of j. I could get rid of the fraction by doing the opposite of what a fraction truly is, which is a division problem. This is really saying 3 divided by 4. If you don't want this divided by 4, you get rid of it by doing the opposite, multiplying by 4. Again, if you ever want to get rid of a fraction, multiply everything by the denominator of the fraction that you want to get rid of. So multiply by 4, that will cancel out. You will have now just a 3j greater than or equal to 15 times 4. Do it on a calculator, you will get 60. How do you get rid of the multiplication of 3 that's right in front of j? You're going to do the opposite of multiplying by 3, which is dividing by 3. So you do to one side, do to the other side. That cancels out. We have j. Do I flip it? Do I change the symbol, or do I keep it? I keep it. It's still a greater than or equal to. Why? Because the only time you actually change it is if you multiply or divide by a negative on your last step. That's when you change the inequality symbol, and we divided by a positive 3, not a negative 3. So 60 divided by 3 is 20. So final answer is j is greater than or equal to 20. If you wanted to draw that on a number line, you could put 20, 21, 19. Because we have a solid line underneath our inequality, that will be a solid dot at 20, not an open dot, a solid dot. And this is greater than, so it's going to the right. Moving on. Once again, you want to get the variable by itself on the left side of the inequality. Get rid of this plus 3 first. How do you get rid of a plus 3? By doing the opposite, minus 3. What you do to one side, you do to the other side, minus 3. Rewrite the whole thing. Negative 2/3 f is less than, and negative 9 minus 3, you owe $9, you owe $3. You're going to owe $12 altogether. You keep it color coordinated, everything black. Okay, so now at this point, you want to get rid of this fraction. You could technically divide by the entire fraction, which would be multiplying by the reciprocal, but I think that might confuse some people. Let's just keep it simple. To get rid of a fraction, all you have to do is multiply everything by the denominator. So multiply this fraction by the denominator 3 and that number by the denominator 3. Now I will cancel out the 3's, leaving us a negative 2f. Bring down the inequality, negative 36. Final step, to get rid of the multiplication of negative 2 in front of f, you're going to have to divide by negative 2, the opposite of multiplying. And of course, what you do to one side, you must do to the other side. So we end up with f, and we did divide by a negative on our last step, so we do have to flip that inequality symbol, make it a greater than, and down here, negative divided by negative is a positive, and positive 18 is the answer. F is greater than positive 18. If this would have been positive, I'd be dividing by a positive, and that would not change. But because it's a negative 2, I divided by a negative 2. And on our last step, we multiplied or divided by a negative. That means we need to change the inequality symbol. That's why it changed from a less than to a greater than. Once again, if you wanted to graph this thing, all you got to do is put 18, 19, 17. This would be an open dot because it does not have a solid line underneath it. So open dot at 18, going to the right. So f is greater than 18 is represented on that number line. Moving on, number 10. What do we have here? We have p's on both sides. You have a p there and a p there. BP. Oh, okay, that wasn't funny. Sorry. Anyway, you want to get p by itself on one side. So let's get rid of one of the p's. I am going to move the 3p to the left side by subtracting it, right? How do I get rid of a 3p? I do the opposite of what 3p is, which is take away 3p, or a negative 3p. That'll cancel it out. What I do to one side, I do to the other side. And of course, you can only subtract 3p's from the other p's, the like terms. So 2p take away 3p is negative 1p. bring down the plus 5, bring down the greater than or equal to, bring down the minus 10, because this canceled out. So now we have negative 1p plus 5 is greater than or equal to negative 10. And p is what you want by itself. So what do we get rid of first, the negative 1 or the 5? Obviously the 5. We're going to get rid of that plus 5 by doing the opposite, minus 5. And when you do to one side, you do to the other side, minus 5. We now have negative 1p is greater than or equal to negative 15. So you could say negative 1p, negative 1 times p, and then divide by negative 1, divide by negative 1. Or you could even just say, I'm going to multiply both sides by negative 1. And if you multiply both sides by negative 1, that'll make it a positive p, and that'll make it a positive 15. But again, on our notes, it says that if you multiply or divide by a negative on your last step, you have to change the inequality symbol. And again, here's our last step, and we're multiplying by negative 1. And it doesn't matter if you multiplied by negative 1 or divided by negative 1. You could have set it up like this, divide by negative 1, divide by negative 1. Either way, it's going to become positive 15, and this is going to have to change. Whether you're multiplying by negative 1 or dividing by negative 1, this is going to have to change to a less than or equal to. So p is less than or equal to 15. On a number line, you'd have 15 right there, 16 on the right side, 14 on the left side, because it's less. And this would be a solid dot because it has a solid line underneath it. Solid dot at 15 going to the left because that is a less than symbol. It looks like it's pointing to the left. The point is towards the left, so it does point to the left. Let's try another. Once again, we have variables on both sides. We have a k on the left side, a k on the right side. So when you're thinking, I want to get k by itself on one side, which side do you want it on? Well, you have it on both sides. You don't want it on both sides. I always want the variable on the left side, right? So I want to get rid of this minus 2k. How do I get rid of a minus 2k? I do the opposite of minus 2k, which would be a plus 2k. That will eliminate. What you do to one side, you do to the other. You're going to add 2k to where the 4k is at. That'll be a 6k plus 15 is greater than 3. 15 comes down, greater than comes down, 3 comes down. So now I only have k on the left side of my inequality. And now I want to get it by itself. How do I do that? I get rid of things by doing the opposite. What is the opposite of plus 15? That would be a minus 15. And what you do to one side, you do to the other side, minus 15. What do we have left? We have a 6k, bring down the greater than symbol, bring down the minus 12, because 3 take away 15 is minus 12. And finally, we have 6 times k is greater than negative 12. So to get rid of that multiplication of 6 in front of the k, we need to do the opposite of multiplying, which is dividing by 6. And what you do to one side is do to the other side. So we are dividing by 6, which will give us the answer k, and negative 2 over here. And the inequality does not flip. It stays exactly the way it is. That inequality just came down. Why did I not change it? The rule says, understand that if you multiply or divide by a negative on your last step, you must change the inequality symbol. Did we multiply or divide by a negative here? No, we divided by positive 6. So it does not change. It does not flip. Well, this video is already kind of long, so I'm going to stop this video right here. I guess on this first video of 5.3 WSPM, we simplified, or actually we solved all the simplified inequalities, right? On none of these did we have to distribute or combine like terms. We didn't have to simplify the inequality. On 12, 13, and 14, we're going to have to do some distributive property. We're going to have to do some combining like terms before we start getting the variable by itself on one side. And I'll pick that up on the next video.